Assalamualaikum. We continue with the next part of infrared spectroscopy. We will focus on the effects of IR bands. The first effect will be discussed about the conjugation. If a compound involved in the conjugation means it have a higher energy required rather than non-conjugated compounds. For example, compound A and compound B. If we can see the frequency for the C double bond O in compound A is less than C double bond O frequency in compound B. Why? Because compound A having conjugation, thus it absorbs lower wavelength than compound B. For the next example, inductive effects are usually small unless coupled with a resonant contributor, for example CH3 or Cl. If we can see the NH2, the signal frequency here, and the Cl and this CH3 is lower than NO2 because this NH2 is strong resonance contributor, this one is poor resonance contributor. That's why the frequency is more higher than this one. This is because of the inductive effect. Next effect is steric effect. Steric effect when the usually not important in IR unless they reduce the strength of a bond. When the interfering the p orbital, so they will have influence the C double bond O frequency. The methyl group in the structure here cause the this structure to be out of plane. The C double bond O become out of plane, so the frequency become more higher than this one because of the steric effect. And the strain effect will change in the bond angle forced by the constraint of the ring will cause a slight change in the hybridization, and therefore the bond strain change. When the strain effect, as the bond angle decrease, the wave number increase because the bond strength become increased. That's why when you see this one is more bond strength compared to this one, the wave number also decrease. So here, significant increase in the frequency of absorption of a double bond contain a ring observed when one or two alkyl group are attached directly to the double bond. The increase of dramatic for small ring, especially cyclopropenes. For example, the base value is 1656 is the base value, increase about 1788 when the alkyl group attached, and if double alkyl there will be 1883. So because of the bond strength increase, so the wave number also will be increased. So next is the electronic effect. Change in the absorption frequency of particular group. For example, if the alkyl group presents in the molecule, for this example, alkyl group presents, this is no alkyl, this one is one alkyl. We can see the force constant of bond strength change in absorption shift from the normal value. The interaction of alkyl group cause positive inductive effect, which result the lengthening or weakening the bond. Hence the force constant is low. When the alkyl group increase, so the bond strength become weaker and the force constant is lower, so the wave number decrease. Let us compare the frequency of C double bond absorption for the following compounds. This one is B without the alkyl group, this one is one alkyl group, this is two alkyl group. We can see when two alkyl group, the bond length become decrease, so it cause the K constant decrease and the frequency also decrease. This is because the presence of I effect. When the I negative effect, inductive negative, means the electronegative atom present, so means it become bond strength become more strange. So the force constant increase, the hence the wave number absorb arise. We can see acetone, chloroacetone, dichloro. When the dichloro it become more higher number because the electronegative atom presents, the inductive effect cause the bond strength increase. In the most cases, mesomeric effect works with the inductive effect. Both can work together. Conjugation lower the absorption frequency, whether the conjugation is due to the alpha, beta isolated or due to the aromatic ring. In some cases, inductive effect dominates over mesomeric effect. Mesomeric effect cause lengthening or weakening the bond leading the lowering absorption frequency. In these two cases, negative I effect dominates the mesomeric effect, thus the absorption frequency falls. This one because of the negative induction effect, and previous slide is because of the positive induction effect. In some cases, lone pair of electrons involved in the conjugation, what happens? Say the carbonyl group mobility of lone pair. For these two examples, let us compare the frequency range for amide and ester. This one, the frequency is quite lower, this one is higher. As nitrogen atom is less electronegative, the electron pair is more labile and participate in conjugation. As we mentioned before, when the electron involved in the conjugation, it make the bond become less strange. So the K constant become lower, so the wave number also become lower. Due to the greater degree of conjugation, the frequency is much less in amide compared to the ester. Let us compare the absorption frequency compounds here. Amino, nitro, methoxy, and phenyl. Due to the low electronegative atom of nitrogen atom, the lone pair of electron participate in more conjugation. Because of low electronegativity, this electron tend to conjugate, so it means have a lower bond strength and lower frequency. That's why the wave number also become the lower. In a compound occurs lower number compared to compound 3. Compound 3 is because of the oxygen is more electronegative. And the inductive effect dominates over mesomeric effect, and hence the absorption take place comparatively higher frequency. This is the example for this one and another structure. The last effect is hydrogen bond. Hydrogen bond cause the broadening the band due to the creation of continent and bond energy. So means in the solution, they are readily apparent the gas phase. The band appears sharp as IR signal. So steric hindrance of hydrogen bond in here. Hydrogen bond can interact with other functional group to lower the frequency. This is the effect of functional group hydrogen bond. So next example, due to the different I effect, which is inductive effect. For the example, for the alkyl CH3 in this compound, so when the alkyl presents, they have a positive I effect and absorption near 1690. For ortho meta substitute inductive, where conjugate display a significant role, and meta substitute, so this one have different. This one is methyl, this one is methoxy, this one is amine. So nitrogen atom, this one is a lower number because it involved in conjugation, and the electron pair nitrogen labile, as previous explanation. This group facilitate in conjugation by electron release and lower wave number. In methyl, para positions cause positive and bring downs. This one positions of the in compound 3, this one is positive, also become brings down the pressure to 16 0.53. Another example how they can differentiate ortho meta for this one in salicylic acid. For show the similar brand due to the OH thresh 3000 to 2500 for both or ortho and meta. Difference in intramolecular hydrogen bond take place. Therefore, the OH thresh shift to lower wave number, as it is intermolecular change in concentration does not cause any shift in OH thresh absorption. In case of meta-hydroxy benzoic acid, the frequency OH still lower value due to the intermolecular hydrogen bonding. Moreover, the absorption band will be broad and position of absorption shift with dilution. Ortho benzoic acid shows a band 735 to 770, while meta-hydroxybenzoic acid shows two band at 960 to 710 and 370 and 770. How to differentiate these two? It is impossible to be differentiate between the hydrogen bond. It cannot differentiate, and only can differentiate between the signal for the ortho and meta in the fingerprint region. That's all. Thank you.